Hello friends, you are heartily welcome to ASIS, the Engineering Foundation. Today, under the distributed system day 2, we are discussing all the points related to distributed system, means introduction of distributed system. I hope you all are also well. I am thrilled to be your guide as we dive into distributed system. Get ready for an exciting journey of learning and discovery. So let's start. In this lecture, we explore the world of distributed system. We learn what they are, how they work, and some of the common features they share. Distributed systems are all around us, powering many of technologies we use every day. Buckle up and get ready to dive in. First of all, we discuss of unit first syllabus. Our main topic is distributed system and subtopic is what is a distributed system versus centralized systems, example of distributed system, features of distributed system, nodes of a distributed system, distributed computation paradigms, model of distributed system. In these topics, today we are discussing above four topics. First is what is distributed system. Second is distributed system versus centralized system and example of distributed system. And last is features of distributed system. And the remaining topic are discussed in the next day. First of all, imagine a team. What is a distributed system? It means through the example we're discussing all about the distributed system. A distributed system is a collection of independent computers that appears to users as a single coherent system. And all components communicate and coordinate action by passing message and work together to achieve a common goal. That's it. It's called distributed system. Imagine a team of people working on a large project. Each person has their own expertise and works independently. But they communicate and share information to ensure the project is completed successfully. That's similar to how a distributed system works. Multiple computers, each with its own resources, collaborate to achieve a common goal. That is called distributed system. Next is what is the difference between distributed system and centralized system? The difference depend on many features like components, resources sharing, software executions, point of control, and point of failure. Here we compare centralized and distributed system. Centralized systems are like having one person in charge of everything. And distributed system are like having a team working together, with each member having some level of independence. This distributed approach offers advantage like scalability and fault tolerance, But it also introduced complexity in terms of managing and coordinating multiple components. It means in the centralized system is a single component and non-autonomous system. But in the distributed system, multiple components are used and each component communicate with each other and all components are autonomous. In the centralized systems, all resources shared by all users, but in the distributed system may not be accessible to all users. And the software executions in the centralized system is single process, but in the distributed systems, concurrent processes on different processor. In the centralized system, the control of point is a single and in the distributed system, multiple point of control. And the centralized system, point of failure, single point. But in the distributed system, multi-point point failure. Next is example of distributed system. Many applications are used distributed systems like telecommunication networks. In the telecommunication network sectors, phone networks, internet, sensor networks, and network applications like websites, online games, database, file system. In the real-time process control, aircraft control, industrial control. In the parallel computations like scientific computing, grid computing. In the distributed system are all around us, they power the internet, online games, banking systems, and even control systems for airplanes and factories. The next time you use a website, play a game online, or make a bank transactions, you are interacting with distributed system. Next, we discuss about the features of distributed system. In the features of distributed systems, these are some key features that make distributed system powerful and versatile. Resource sharing allows us to tap into the collective power of multiple computers. Next is openness. Openness enables flexibility and easy integrations of new components. Next is concurrency, helps to achieve faster processing and efficient resource utilization. Next feature is scalability. It means it allows the system to adapt to growing demands. It means allows the user to grow as the number of user increase. Next feature is fault tolerance. It means it ensures continue operations even during failure conditions. Ensure the system remains available even if components are failed. In the transparency features makes the system appear seamless to user and programmers. It means hides the complexity of the system, making it user friendly. It means the system developed user friendly. Next features is heterogeneity. Heterogeneity accommodates diverse components with different hardware, software, and implementation. It means it allows us to leverage diverse technologies and platforms. These are the seven main characters characteristics used to access distributed system. We will delve deeper into each of these characteristics in the following slides and discuss each features one by one in deeply. First of all, we discuss resource sharing. It means what is resource sharing? In our minds, first question generate what is resource sharing? Resource sharing allows applications and users on different computers within a distributed system to access and utilize hardware, software, and data from other computers in the network. It means resources can be accessed remotely across multiple computers. What benefits of resource sharing? Benefits are some benefits are include in the resource sharing like cost reductions, improved convenience, data consistency. In the cost reductions means by sharing hardware resources like printers and storage, organizations can avoid purchasing duplicate equipment for each computer. And improve convenience means user can access shared resources like files and applications from any computer on the network, regardless of location. Next is data consistency. Data consistency means sharing data centrally ensure everyone has access to the latest information, promoting collaborations and reducing inconsistencies, and managed by a software module called a resource manager. It means what is management? A software module called a resource manager is responsible for managing access, allocations, and control of shared resources. Resource sharing is a fundamental concept in distributed system. It allows us to pool resources from multiple computers, making them available to users and applications across the network. This shared access can be beneficial in several ways. We can share hardware resources like printer and storage to avoid duplications and save costs. We can share data to ensure everyone has access to the latest information and facilitate collaboration. A dedicated software module called a resource manager. Imagine a company with multiple offices. Instead of each office having its own printer and server, a distributed system allows them to share these resources across the network. This reduced cost. It means no need to buy duplicate hardware for each location. Improve convenience. It means everyone can access the shared resources from any office. Ensure consistency means files and data are stored centrally accessible to everyone, promoting collaboration. Next feature, openness. That means first question generate in our mind what it is. What is openness? The openness refers to the ability of a distributed system to be easily extended and improved by incorporating new components. It means open to both hardware and software integrations. What benefit? What importance? Just like a city needs well-defined roads and signage for new buildings to connect, a distributed system needs to be open for easy integrations of a new component. This allows the systems to adapt to changing needs. It means new functionality can be added by integrate new component. Leverage new technology. The system can benefit from advancement in hardware, software, and communication protocol. It requires defined and published interfaces, standardized interfaces, easy integrations of a new component. How it's achieved? Well-defined interfaces means detailed specifications on how components communicate and interact with each other are published. Second is standardized interfaces. Consistent communication protocol ensure components from different vendors can work together seamlessly. Easy integrations means new components should be designed to connect and work with existing one without significant modifications. Think a distributed system like a city. Just like a city needs well-defined roads and signage for new buildings to connect easily. A distributed system to create for needs to be open for easy integrations of new components. This is achieved by publishing details and well-defined interfaces. These acts as instructions on how components and communicate to and interact. Standardized interfaces means this ensure consistency and reduced development complexity. Facilitating easy integration means new components should be able to be seamlessly connect and work with existing one. Next feature is concurrency. Concurrency means concurrency refers to the ability of a distributed system to handle multiple activity or tasks happening simultaneously. Ability to execute multiple activity. Activity runs on different machines and may interact with each other and reduce latency and increase throughput. These are benefits. The first benefit is reduced latency. It means tasks can be processed faster because they don't have to wait for each other to finish. And second benefit is increased throughput. It means the system can handle more work by processing multiple tasks concurrently. Next is improved efficiency. Resource like processors and network bandwidth can be utilized more effectively. How it works? Multiple activity. The system can support multiple activity running on different computer within a network. Interaction between activity means these activity can exchange information and coordinate their actions as needed. The concurrency understand by the example like just imagine a busy kitchen with multiple chips with multiple shapes, sorry, working simultaneously. Similarly, a distributed system supports multiple activity executing at the same time. This can occur on different computers within the system. Interaction between these activities, they can exchange information, coordinate their actions, reduce latency, and increase throughput. Next is scalability. Imagine a website that starts small but become widely popular. A well-designed distributed system can handle this growth by ability to handle growth in the number of users, adding more computers. It means the system can be easily expanded by adding new computers to the network. Second is distributed workload. It means distributing workload. Tasks can be distributed across multiple computers, improve overall processing power. And third is maintaining performance. Even with increased load, the system should maintain acceptable performance level. Scalability is crucial for distributed systems because they are often used for applications with growing a huge user base or complex computational needs. The components should be designed to be scalable. Next is fault tolerance. Imagine a power outage affecting one of the computers in a distributed system. A fault-tolerant system can handle these by ability of the system to continue operating despite failure. Failure can occur in hardware, software, or the network. What techniques are used for fault tolerance? A fault tolerant system can handle this by redundancy. It means having backup components like servers, storage devices, and network connections. If one fails, another can take over seamlessly. Second is error detection and corrections mechanism. It means mechanism to detect and correct error in the data or communications. In case failover, switching to a backup system in case of failure. Next is self-healing automatic detections and recovery from failures. Graceful degradation. Even if a component fails, the system should continue operating at a reduced capacity rather than shutting down entirely. Fault tolerance is essential for distributed systems because they are often used for critical applications that require high availability and reliability. Second, and next is transparency. Imagine using a website without knowing it's actually running on multiple computers scattered around the world. Transparency in distributed system many amps makes the distributed system appears as a single unified entity to user and applications. We conclude different types of transparency, but what aims of transparency? First aim is simplify user experience. It means users should not need to be aware of the underlying complexities of the distributed system. They should interact with the system as if it were a single entity. Second aim, reduce programming complexity. It means developers should not need to worry about the intricacy of distributed communications and resources management. They should be able to focus on the application logic. Transparency achieved through various mechanisms. such as access transparency. Access transparency means user can access resources like files and applications in a consistent manner, regardless of their location on the network. Next is location transparency. It means users don't to know where their data is physically stored or which computer is processing their request. Third mechanism is concurrency transparency. It means the system manages the complexities of the concurrent activities, making it seem like tasks happen sequentially from the user's experience and user's perspective. Next is replication transparency. It means users unaware of data replications. Next is failure transparency. It means user unaware of the system failure. And next feature is heterogeneity. Imagine a distributed system that can connect a powerful server with a low-end mobile device. Refers to the diversity of compute components within a distributed system that is called heterogeneity. Heterogeneity can exist in means heterogeneity in network, different type of network protocol and technology like Ethernet, Wi-Fi, cellular. Second is hardware, different types of computer hardware. Example, processors, memory, capacities. The heterogeneity allows flexibility, integration, scalability. Flexibility means the system can be built using diverse components from different vendors, depending on needs and budget. Second is integrations, means new component with different technologies can be easily integrated into the existing system. And third is scalability. Heterogeneity facilitates scalability because different types of resources can be added as needed. How we are managing heterogeneity? Introduce some challenges such as ensuring compatibility and communication between diverse components. By incorporating these features, distributed system offers advantage like resource sharing, scalability, fault tolerance, and user-friendly experience for various applications and services. Heterogeneity existing in operating systems, like different operating systems on different machines, like Windows, Linux, Mac operating system. Heterogeneity exists in programming language, application developed in different programming language, and exists heterogeneity in implementation. System built by different developers using different approaches. Here are some assignment questions for you to practice as like first is what is distributed system. Second is difference between centralized system and distributed system. Third is explain features of distributed system. Thank you very much for watching this video. To see more videos like this, please like, subscribe and share our channel with your friends so that you and your friends can also get the benefit of this video. See you in the next video with a new topics. Thank you.